So in this problem, we're looking for the probability that x is greater than or equal to 8. And we're told that x has a binomial distribution with n equals 10 and p equals 0.7. And in the first part, you found it using the exact binomial probabilities. But now we're supposed to use the normal approximation. Well, anytime you want to use the normal approximation, you need to find your new mean and your new standard deviation. Before you spend all the time doing that, though, you should probably check that your sample size is big enough. So over here off to the side, let's check that our sample size is big enough, because otherwise there's no point doing the problem. So we want to see if n times p is at least 10. So n is 10, our probability is 0.7. Sorry, actually, some textbooks use 10 as a rule of thumb, some textbooks use 5. Our textbook says 5. Now that's just if you really want to make sure you'll be accurate, use 10. If you're okay with it, it's pretty accurate, you can use the 5 rule. So 10 times 7 equals 0.7, so that's good. And then if we check n times 1 minus p, that's going to be 10 times 0.3, which is 3, which is not big enough. Now, so we did get 3, that is not at least 5. Okay, so we should make a little note here on our problem that this approximation might not be as accurate because the sample size isn't big enough. So when we're done, we'll look at the exact probability versus what we got from our approximation. Now, one of my biggest pet peeves about most textbooks is they tell you only do this thing if your sample size is big enough, but then on most of the homework problems, they give you sample sizes that aren't big enough. And if you didn't do any of those problems, you just wouldn't have enough practice. So we'll still do the problem for practice, but we'll keep in mind that the approximation might not be as good as we want because the sample size is not big enough. So now for the actual approximation. So again, anytime you want to do normal approximation, you need to find, well, what is my new mean? Or my mean for a binomial. Your mean is going to be n times p. So again, that'll be 10 times 0.7, which is equal to 7. And you need to find your standard deviation. Standard deviation is the square root of variance, which is n times p times 1 minus p. So this will be the square root of 10 times 0.7, and 1 minus 0.7 is 0.3. Putting that into my calculator. I get 1.4491. Now, keep in mind, the textbook does not round. They put all of this in all at once, so your answer might be slightly different because of rounding. Okay, so we found the mean, we found the standard deviation. Next step when you do a normal distribution is to standardize. So z is always equal to x minus the mean over the standard deviation. So the x we're interested in is 8. So we'll put in 8. But now remember, this was a binomial distribution. So it's something discrete like this. We don't actually have all of the values. So if this is 8 right here, to find a probability, we always add or minus 0.5 to make our area bigger. So we found out the approximation works bigger if you either add or subtract the 0.5 to make it bigger. So if this is 8 and I'm looking for the area to the right, to make my area bigger, I would want to go this way to make it bigger. So we will subtract 5 and go to 7.5. So we'll do 8 minus 0.5. So I don't try and memorize the rules. I just draw a picture and say I want to make it bigger by 0.5. So in this case, I mean going back to the 7.5. So we have that minus our mean of 7 over 1.4491, which gives me minus 0.5. 0.3450. So now we have to pull out our calculator. Not our calculator, I'm sorry. You could use your calculator. I'm going to use the normal table. Keep in mind, again, that your textbook does not use the normal table. Your textbook uses the solutions manual, I should say. The solutions manual uses a calculator, so their results will be slightly different. So we are looking for a z-value of 0.345. That was not a probability, even though it was a decimal. That is my actual z-value of 0.345. So go to your normal table and look for 0.345 would be somewhere about here. You can just pick one. I mean, it's 0.345, so it's right here in the middle. So you can pick one, you can take the average. Since it's right in the middle, I might try and take the average, so like 0.6345 or something maybe. Now, again, your calculator gives you a better result than this. In fact, let me check what it is on the calculator. So I actually guessed pretty well. On the calculator is 0.6349. So pretty close either way. So come back over here. When I looked at my z table for z equals 0.3450, I got an area of 0.63. I'll just do the 490 even though I'd guess 45. But notice that is the area to the left. I wanted area to the right, but my table doesn't give that to me. It always gives me areas to the left. So we'll have to do 1 minus 0.6349, which gives me 0.3651. So my area to the right is 0.3651. Now, if you looked at the exact value, instead of doing this approximation, let's see what that was. So the exact was 0.3823. Our approximate, sorry, my handwriting is really bad because I couldn't detach my screen because my battery was dead. Okay, so notice my exact is 0.3823, my approximate is 0.3651. Those are not very close. Again, that's because our approximation was not accurate because our sample size was not big enough.